Chaitanya, Physics Faculty at Shakthi International School. In this video, we are going to learn an important topic of system of particles and rigid body dynamics, that is moment of inertia and theorems of moment of inertia. Theorems of moment of inertia. These two topics will talk. You know what is moment of inertia? Moment of inertia is a tendency of a body to resist the rotational change. Tendency to resist rotational change in rotational state. Rotational state. That means if let's say there is a ring here, that ring is at rest. Okay, if you are trying to rotate it, okay, it will resist because it is having moment of inertia. Let's say if this ring is rotating, then if you want to stop it, you have to apply torque on it. Okay, you have to apply a torque on it. Now otherwise, if there is no torque being applied on it, it will resist that. Okay, it will not be able to stop again. Okay, so that means if you want to change the rotational state of the object, we have to apply some kind of torque, not just force, we have to give a torque. Okay, the same analogy of motion what we are having in terms of force, in this you have to analyze in terms of torque. That I hope you understood what is moment of inertia. And the moment of inertia I, we represent it with the letter I, will be given if m is the mass of the object and r is the distance. Let's say if this, we are taking an example of one small object. Let's say we are taking an example of one small object from the axis. This is your axis of rotation. From this axis of rotation, we are having small object of mass m. It is at a distance r. Okay, so the moment of inertia of it is defined as mass of the object into square of the distance between them. Let's say if there are n number of objects, then I will be written as m1 r1 square plus m2 r2 square plus up to so on mn rn square. This is the general formula of moment of inertia. Now, in this moment of inertia, this is for individual particles. For a continuous objects, moment of inertia I can be written as integral of dm into r square. So now, if you are integrating the smallest masses of all the entire object, you will be getting the total mass. This is how we can write moment of inertia for continuous objects. Now, you have to get an idea of what is radius of curvature also. Radius of gyration. Radius of gyration. We have to analyze what is radius of gyration. Now, when you are learning about radius of gyration, let's say we take an example of one continuous body. It is in this uneven shape. Let's say it is rotating around this axis. On this object, there are n number of particles. You can consider this as m1 mass, this particle as m2 mass, and this particle as m3 mass. They are at different positions. If you are considering the total moment of inertia, you are going to write it as m1 r1 square plus m2 r2 square plus up to so on mn rn square. If you are considering all the particles are having the same mass, if m1 is equal to m2 is equal to m3 up to so on mn, then you can write moment of inertia I as m into r1 square plus r2 square plus up to so on rn square. So this is the general formula of moment of inertia for that particular body. Now, okay, now this is the general formula of moment of inertia of that entire particular body. In this case, if you are trying to analyze what is the total mass, for total mass you can write it as total mass of the body can be written as, if let's say n of such particles are there, n into m. So m is n into m. This is how you can write total mass of the body. Let's say, according to the condition of radius of gyration, if all these particles are assumed to be at one particular point, that means the entire mass of that object is assumed to be at that one particular point. Let's say this is the axis of rotation and the entire object mass, you are writing it as capital M here, which is equal to nm. It is at some distance k. Now the distance that you will be getting by assuming the entire mass at one particular point from the axis of rotation is what we call it as radius of gyration. In this case, if you are writing the moment of inertia, you can write it as m into k square, m into k square, where m is the total mass and k is the distance from that particular axis of rotation. So that means whatever the formula that you have written, which is mk square before, or m into r1 square plus r2 square plus up to so on rn square, are equal. That means if you are substituting in this in the form of m into n, k square is equal to m into r1 square plus r2 square plus up to so on rn square. So now these two m's gets cancelled. So the value of k that you will be getting it as r1 square plus r2 square plus up to so on rn square divided by n. This is a general formula for radius of gyration. I hope you understood what is radius of gyration. Now we will understand what is the theorem of moment of inertia. We are having two theorems of moment of inertia. Okay. Before that, let me give you some general formulas of moment of inertia. Moment of inertia of some common shapes or objects. Always remember, the moment of inertia of a rod along the axis passing through the center of mass is m L square divided by 12 if L is the length of that rod. Okay, passing through the center of mass. Now this is the center of mass. This axis of rotation is passing through the center of mass. Second one, let's say we are having a ring, okay, of mass m. This is a ring of mass m. The moment of inertia for it is given as m r square, where r is the radius of that ring. Third one is a disk. This is a ring, this is a disk. Now through this disk, let's say if it is having mass m, the moment of inertia of this disk is given as mr square divided by 2. Okay, that is a general formula for moment of inertia of a disk, that is I is equal to mr square divided by 2. This is the general formula of disk. Now we will come to this once we have finished the theorems of moment of inertia. We will analyze what is the perpendicular axis theorem, and parallel axis theorem. In perpendicular axis theorem, we can apply this perpendicular axis theorem for only plane objects, plane or two-dimensional objects. Parallel axis theorem can be applied for any shapes. Okay, not just 2D or not just 3D, it can be applied for any shapes. According to perpendicular axis theorem, what you will be understanding is, let's say there is one object. Okay, if we are defining a plane for it, this is x plane, this is z plane, and this is y plane. According to perpendicular axis theorem, the moment of inertia along three different axes we can find: iz, I, y. Always the sum of moments of inertia passing through the plane through the plane of object is equal to moment of inertia of the object passing perpendicular to the object. Passing perpendicular to the object. That means in this equation, Ix and Iz are the moment of inertia which are passing through the object, through the plane, okay, and Iy is also passing through the object, but it is perpendicular to that plane. So this is what is given by perpendicular axis theorem. We can apply this theorem only for plane objects or 2D objects. Now further, if you are analyzing it, if plane is symmetric, if plane is symmetric, then Ix can be equal to, will be equal to Iz. Okay, so this is the important condition you have to analyze. Okay, next, in case of parallel axis theorem, what does parallel axis theorem explain is, this can be applied for any shapes. According to this, let's say if there is a particular shape, this is the axis which is passing through the object, center of mass. This is having moment of inertia I, let's say, or moment of inertia through center of mass, let's say I am writing it as I center of mass. If they are asking moment of inertia passing parallel to that particular axis, let's say the distance between these two is r, okay, the moment of the mass of the object is m, the moment of inertia through center of mass can be written as m into k square. We don't know what is the value of k, it can be simply written as m into k square. Okay, next, since r is the distance from the plane, from that particular axis to the another axis which is parallel to, which are parallel to each other, then only we can use this parallel axis theorem. So these are parallel to each other, we can use parallel axis theorem. Now I through this center of mass, I through this point which is parallel to that can be written as I through center of mass plus m r square, where r is the distance between them, m r square. So this is the rule or theorem, law according to this theorem. So center of mass through any axis parallel to the axis is added by the distance, mass into square of the distance between them. So this is how we have to analyze. Okay, now if you are trying to understand the same for these objects, if I am asking you to find what is the moment of inertia of this rod from a particular end, okay, so now from the center the axis is shifted a distance of L by 2, so you can write this as ml square by 12 plus mass of the object into shift in that. What is the shift in it? L by 2, so L square by 2, so it will be ml square by 12 plus ml square divided by 4, which will be giving me ml square by 3. That is the moment of inertia for the rod from the edge. Now for the ring, if we are asking, then the ring from the edge, if you are asking, it will be 2mr square. Next, for a disk, if we are analyzing, for a disk we can analyze both the dimensions, that is according to parallel axis theorem we can do, and according to perpendicular axis also we can do. According to parallel axis theorem, let's say if I am asking it from the edge, then you can write it as mr square by 2 plus mr square. In perpendicular axis theorem, let's say if I am asking you to find moment of inertia along this plane, Iz plane, then you know this is your y, this is your z, this is your x. So you know Iy is equal to Iz plus Ix. Since Iz and Ix will be equal, since this is completely symmetric, you can write it as 2Ix is equal to Iy. Let's say if I am asking you to find along Ix, you can write it as Iy divided by 2. Iy you already know it is mr square divided by 2, divided by 2 means mr square divided by 4. So the moment of inertia of this along the z direction or x direction, Ix is equal to Iz is equal to mr square divided by 4. In this way, if you know the moment of inertia of the object, you can find the moment of inertia of the object along any other axis, either it is being perpendicular or it is being parallel, we can find it. I hope you understood this one. Thank you.